Okay, we're going to take a look at the stem and leaf display. This is the first approach we're going to look at as far as giving a visual description of data. A distribution of a numerical variable represents the data values of the variable from lowest to highest value, along with the number of times each data value occurs. The number of times each data value occurs is called its frequency. In other words, a distribution is a presentation of data along with the number of times each data value occurs. Distributions can be presented in several ways. We can have a graph, a chart, we can have some other sort of picture. In this example, in this class, we're going to start by creating a distribution image by looking at a stem and leaf display. An outlier is an individual data value which lies far, either above or below, from most or all of the other data values within a distribution. So if you consider a distribution of test scores where most of the test scores are between 60 and 90, if a student receives a score of 20, we would consider it an outlier because it is far below most of the other data values within the distribution. A student who received a score of 100 may also be considered an outlier. And we're going to look at precise mathematical methods for distinguishing outliers in future lectures, not this lecture today. A stem and leaf display is a visual, exploratory data analysis technique that shows the shape of a distribution. The display uses the actual data values of the variable to present the shape of the distribution of data values. Here's an example of a stem and leaf display. We have this portion of the display called stem, and we have this portion called leaves. In this example, the stem begins at 1 and ends at 6, and the leaves are labeled to the right of each stem. How do we read this thing? Okay, each data value starts with a stem and ends with a leaf. What are the data values in the first row? What are the data values in the fifth row? Well, the way we read this is we look at the stem in the first row, it's a digit of 1. We look at the first leaf in the first row, which is a digit of 0. Therefore, the very first data value of this distribution is 1, 0, or 10. The next data value in this distribution is 1, 7, or 17. And then the next data value in this distribution is 1, 9, or 19. So the first row contains the data values 10, 17, and 19. And we can continue. The second row contains the data values 21, 21 again, 23, 24, 26, 27, 28, and so forth. If we look at the fifth row, we have a stem of 5 but no leaf associated with it, in which case there is no data values in the fifth row. Therefore, there are no data values that have that exist in the 50s. So we jump from 42 all the way to 69 with nothing in between. Now, it is important to indicate that there is a gap in data by leaving that 5 in the stem column. With the 5 in the stem column, we can really see visually that we have a gap in our data, which could mean something. It could help us detect outliers, and that's why we leave that 5 there. Okay. We are going to create our own stem and leaf display from this raw data set right here. Cholesterol levels of 50 middle-aged men on a regular diet. and we have the measurement is the units are milligrams of cholesterol per 100 milliliters of blood. We have, I think, about 50 data values. Yes, 50 middle-aged men, so we have 50 data values. Each of these data values are going to go into a list on your calculator. So let's see if you can remember how to put data in a list. Okay, I've already got my data values into L2. I would like you also to put these data values into L2 and then sort them in numerical order. So let's recap how to do that. You're going to, where is it? Here it is. Okay, L2 is right next to L1. If you want to slide over to L2, let's first recap how to get back to this screen. You're going to press Stat, and then with one edit highlighted, hit enter. Your cursor is the blackened area. To move over to the next row, you're going to hit the right arrow right here, and that would move you into L2. Now, if you already have data into L2, you can clear it by going up to the name L2, pressing the clear button, and then hitting enter. I'm not going to do that because my list is already filled with these cholesterol values for these 50 middle-aged men. I've not sorted it yet, so if you want, pause the video, put in your data values for the cholesterol values for these men, and then when you're done, start the video again and I will sort it with you from in ascending order. Okay, to sort in ascending order, we go Stat, we use our down arrow and hit Sort Ascending, Sort A for Sort Ascending, hit enter. We identify the list we want to sort, which is L2. Notice that's in blue above the 2 key. So using our second key and then the 2, that would access the L2. Close the parentheses and hit enter, and you're done. To see that sorted list again, you can hit Stat, then enter on edit, and note how now L2 begins with the 199, 199, and those are the two smallest values from that data set. Okay. Okay, so now that the data is sorted in numerical order, you're going to identify what should be the stem in your stem and leaf display. The stem and leaf portion of the data values. Generally, the stem can have as many digits as needed to represent the beginning digits of each data value. The leaf should only contain the last or terminating digit of the data values. Okay, so let's break this down. We're looking at if for example, we're looking at data value 263, we're going to leave 3 as our leaf because the leaf is always the terminating or last digit, that's 3, and 26 would be the remaining digits in front that make up the stem. So for data value 263, 26 is the stem, 3 is the leaf. Let's suppose that our data value had 4 digits, like this, 2631, for example. If our data value were 2631, then 1 would be the leaf and 263 would be the stem. Okay, the very last digit would be considered the leaf and everything else is considered the stem. Okay, but for this problem, because we're dealing with 3-digit numbers, the first 2 digits make the stem and the last digit makes the leaf. And once you've identified the stem portion of your data values, identify the smallest stem and the largest stem. Okay, so if the stem portion are the first 2 digits, we have to figure out what's the very largest stem, what's the very smallest stem from our data values. So we go to our calculator again. And going to our calculator, we have 199 as our smallest data value, and therefore 19 is our smallest stem. If we use our arrow key to go all the way down to the very end, we'll get to the largest data value. But there's also a quicker way. If we press the up arrow and then the up arrow again, it brings us to the bottom of the list, and here's the largest data value, 319. So 31 is our largest stem, 19 is our smallest stem, and 31 is our largest stem. Okay, so once those values are identified, we create the stem. Okay, so 19 is the smallest, 31 is the largest. Therefore, we're going to create a stem of data values from 19 to 31. We list each possible stem once in a vertical column, starting with the smallest stem on top and ending with the largest stem on bottom. We list all the numbers between 19 and 31, even if the stem contains no corresponding leaves. We draw a vertical line to the right of the column of stems. So this is what you should create: a single vertical column of two-digit numbers beginning at 19 and ending at 31. These are considered the stem. Now, there may be some stems that don't have any leaves, but like I demonstrated before, it's important to leave those stems in the column because we want to see gaps if there happen to be gaps of data. The gaps indicate that we may have an outlier, and we like to see that. So copy down the stem 19 to 31, getting every digit between 19 and 31. And then you create a vertical line to the right of the stem. Okay, for each data value, record the leaf within the corresponding stem row to the right of the vertical line. So we're going to go and look at our calculator for this. Going to the very top of our calculator's L2, we see our first digit, our first number is 199, our second is 199. For the stem 19, we're going to record a 9 in the leaves column and then another 9 in the leaves column. This would indicate that we have data values 199 and 199. For the stem of 20, we're going to record a 0, then a 1, then a 2, then another, oh, sorry, that's it. We're just going to record a 0, then a 1, then a 2. Going down, for a stem of 21, we have more now. Let's see. For a stem of 21, we're going to record a 2, a 3, a 5, and a 9. And we're going to go through the entire calculator list in this fashion until we've reached the end. And when you do reach the end, this is what you should see. The leaves should be increasing order from left to right. So that's why we sort the list ahead of time on the calculator. Sorting the list is going to allow us to put these in ascending order from left to right without thinking of it. So, like I said, the first digit under the leaves column is a 9, indicating we have data value 199. The second digit is another 9, indicating we have a second 199. The second row, we have a 0, 1, and 2, indicating that we have data values 200, 200, 201, and 202, and so forth. When you get down to the 290s and the 300s, you notice that there are no data values in the 290s, and there are no data values in the 300s. These stems, 29 and 30, should be retained. It's important to see that jump of data, that gap, because the 319 should stand out as being far away from the other data values in the distribution. Now, if you're a little familiar with the bell curve, if you've ever seen a bell curve used in psychology or any other mathematics, you may notice that if you tilt your head to the right, you kind of can see the outline of a bell curve appearing in this data set. And that's something that we're going to see a lot of this semester. Okay, so if you need, pause the video so you could record all of the leaves on your own stem and leaf display, and then unpause when you're ready to start again. Okay, now we're going to look at the cholesterol levels of 50 middle-aged men on a low-fat diet. So the 50 men that we just made the stem and leaf display for were on a regular diet, and this is the 50 middle-aged men on a low-fat diet. Now, these data values are already in your calculator in L1, and they have been sorted in ascending order. So you're going to create a stem and leaf display based on this data now. So we already put the data into an empty list. We put it in L1 earlier, and we sorted it in ascending order. We're going to create a stem and leaf display. We're going to find the center of the distribution. The center meaning the center data value of the distribution. And we're going to locate the stem with the greatest concentration of data values. Okay, so once that's complete, this is what it should look like. So let me take you to the calculator and just demonstrate how you produce this stem and leaf display. You look at L1, and in L1, it's already sorted. You make note of the smallest data value, which is 161, which means that the stem is 16. Going up one again, the largest data value is 231, which makes the largest stem 23. So the stem ranges from 16 to 23. So when you create that stem, you should create a column, a vertical column of data values from 16 to 23, including every single number between 16 and 23. Then you make your vertical line, and then you go back to your calculator and you count, starting with the 16s, how many data values do you have that begin with 16? You have 161, 165, and 168. So your first row is going to contain data values 1, 5, and 8. So you go to the row for 16 and you create a row of leaves 1, 5, and 8. So this would be 161, 165, 168. And then for the 17s, you have 171, 172, 172, 175, 176, 176, 177. Okay, so there's quite a few 17s. You've got leaves 1, 2, 2, 5, 6, 6, 7. So when you go to the row for 17, 1, 2, 2, 5, 6, 6, 7. And you're going to continue this for all of the data values in your distribution. That should be in L1. So take a minute and complete your distribution until it's completed and it looks like this, and then you can come back to the video when you're ready. Notice that when the leaves are created, they're created in perfect vertical lines. That's very important. That makes it obvious, therefore, that when we're asked a question like which stem contains the largest concentration of data values, it's easy to see which one it is. It's the one that goes furthest out to the right, which we can see right here is number 19. Okay, because that 9 goes furthest out to the right than any of the other rows. Okay, so it is important to create perfect vertical lines when you're creating the stem and leaf display. Okay, the center of the distribution. The center is the middle of the distribution, the middle data value. So take note, we have 50 data values here. The center, if you have 50 data values, the center is going to be between the 25th and the 26th data value. Okay, so the center of the distribution occurs between data values 25 and 26 because there are exactly 50 data values. And if you need some help understanding that, well, consider what happens when you have 6 data values. If you have 6 data values, you have 3 on one side and 3 on the other. If you're considering the data values imagine the data values laid out in a line. If you have 6 of them, you have 3 on the left, 3 on the right. So the very center of that distribution would be between the 3rd and the 4th data value. And so if you have an even number of data values, that's what happens. The center is between the 25th and 26th when you're dealing with 50 data values. If you're dealing with something small like 6 data values, the center would be between the 3rd and the 4th data value. So to find out where the 25th and 26th data value are, we start counting at the 1 here. This is the first data value, 5 is the second, 8 is the third, and we're going to continue till we hit the 25th and the 26th. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. So 197 is the 25th data value and 198 is the 26th data value. So the center of the distribution falls between cholesterol values of 197 and 198. Okay, so the center of the distribution is between those two numbers. The stem with the greatest concentration of data values, here's where it becomes really important that we have these perfect vertical lines. It's easy to see that since the stem with 19 goes furthest out to the right, this is the row that's got the most data values, and therefore it is the stem 19 that's got the greatest concentration of data values. Okay, because how many data values are in, or rather how many leaves have a stem of 19? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And that's more than any other stem.